In this segment, we're going to keep on looking at the inverted index and see how it's an efficient data structure for doing query operations in an IR system. And in particular, we'll step through and detail how you can perform a common kind of query, an AND query for two terms. So starting off now, we'll look at the details of query processing, and then we'll have a later segment where we'll talk even in more detail about the kind of queries we can process. So suppose we want to process a query. So suppose our query is Brutus and Caesar. Well, let me even do a simpler example than that. Suppose the very first kind of query we want to look at is just a query for Brutus. Well, how to do that is totally straightforward. What we do is locate Brutus in the dictionary, and then we return its postings list that we look up and say, okay, this is the set of documents where Brutus occurs, and we don't need to do anything else. But now let's go to that fraction more complicated case. Well, then we're going to locate, for Brutus and Caesar, we're going to locate both the words in the dictionary, look up their postings lists, and what we'd like to do is then work out what are the documents that contain both Brutus and Caesar. And doing the putting them together is standardly referred to as merging the two postings lists. Now, that term can actually be misleading because what we're doing for an AND query is we're actually intersecting the two sets of documents to find the documents in which both words occur, whereas merging suggests doing some kind of putting them together in a union operation. But the term merge is used actually in both cases. So the merge algorithm family refers to a family of algorithms where you can step through a pair of sorted lists and do various Boolean operations on it. Let's look in concrete detail how that happens. Okay, so the way we do a merge operation to do Brutus and Caesar is like this. We start with a pointer which points at the head of both lists. And what we're going to be wanting to do is then work out what's in their intersection. So the way we do that is we ask, are these two pointers pointing at the same and equal doc ID? And the answer is no, and so what we do is then advance the pointer that has the smaller doc ID. So now our two pointers are like this, and we say, are the two pointers pointing at the same document ID? And here the answer is yes. So we put that into a result list. And then if we've done that, we can then advance both pointers. We now say, are these pointers both pointing at the same doc ID? No. Is the first list the thing pointed to by the first list pointer greater than the thing pointed to by the second list pointer? No, so we advance the bottom pointer one. Then we say, is the doc ID pointed at by the two pointers equal? No, and so again we advance the smaller one. Equal, no, advance the smaller one. At this point, they're again both pointing at the same doc ID, so we add that to our result set and we advance both pointers. Are they the same? No. What we do is advance the smaller one. Are they the same? No. We advance the smaller one. Same? No. Advance the smaller one. Same? No. Advance the smaller one. Same? No. And at this point, when we try and advance the smaller one of our lists is exhausted. And so then there can be no other items in the intersection, and so we can stop. And so this is our return document set. Documents 2 and 8 contain both Brutus and Caesar. So I hope we went through that carefully enough that you can see that if the list lengths are x and y, then this merge algorithm takes big O x plus y time, that it's linear in the sum of the lengths of the two postings lists. And you should also have seen what's crucial to make this operation linear. And what's crucial to making it linear is the fact that these postings lists were sorted in order of document ID. Precisely because of that, we could do a linear scan through the two postings lists, where if that hadn't been the case, then it would have turned into an n-squared algorithm. Okay, here's the postings list intersection algorithm one more time as a real algorithm, but hopefully you can see it's doing exactly the same as what I was by hand. So we start here with the answer set as 0, and then we're going to be doing this while loop while the postings lists are both not equal to nil, because as soon as one's nil, we can stop. So that's the AND operation. Okay, so then at each step, what we do is ask whether the document ID of the two pointers is the same. If so, we add it to our answer. If not, and if they are the same, we can advance both pointers. And if not, we work out which doc ID is smaller, and then we advance that pointer, so either this one or this one. And that was exactly what I was doing. And then as soon as one of the document lists runs out, we can return our answer set. Okay, I hope that made sense, and you now feel like you could write your own code to do the intersection of postings lists using the merge algorithm.